Dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 532. In this lecture, we will try to understand growth of biological neural network. How a biological neural network looks like. The big question here is, how does a biological neural network get built up? So, neural network here is nothing but basically an interconnection of neurons. So, if this is my cell body, let me assume this is my cell body, this is my cell body, this is cell body, this is cell body, this is cell body. Isn't it? These are the dendroids. Which one is dendroids? These are known as dendrites incoming to the cell body, isn't it? These are my axons. Outgoing links from the cell body is axons. Outputs are get connected to other neuron. These outputs can get connected to other neurons. This is literally what a biological neural network is. Basically, dendrites are inputs, axons are outputs. That's what we discussed in our previous lecture. I request all of you to refer my previous lecture before understanding this lecture. In this interconnection, various neurons, biological neurons, is your biological neural network. The big question here is how this biological neural network form, isn't it? So it is very interesting study in neuroscience. So when you are born, you have bunch of neurons. Let me show a nice example. So this is an example from Harvard child development, isn't it? This particular example I collected from Harvard child development developingchild.harvard.edu. How child development happens. They have taken what they did. They have taken a small piece of brain. Yes, here you have brain. From that particular brain, they collected a small piece of brain. This is this I can say a small piece or slice of the brain. This is something like small piece or slice of the brain, isn't it? And visualizing each individual neuron under microscope. This research is very old. This research was done in 1959 and it's nothing new. This is basically from human what is that? I can say this one is cerebral cortex. This is from human cerebral cortex. Cerebral cortex is front part of the brain where the most of your thinking and cognition happen. When a kid is at birth, there are some neurons at birth. There are some neurons. This is the cell. I can say these are the cell bodies, isn't it? This at birth, cell bodies. This is cell body. This is cell body. This is cell body. Cell body. All these are cell bodies, isn't it? Now this is actual scan under microscope. There are some dendroids and axons. You can see the dendroids and as well as what is dendroid? Incoming signal. Incoming is dendroid, isn't it? Outgoing are axons, isn't it? Yes, there are. This is actual scan under microscope. There are some dendroids and axons. If you look at it, the network is not fully formed. The network is very sparse. When I say the network is sparse, what I mean is there are very few connections from one neuron to other neuron. There is a connection from just if you observe this one, there is a connection from this neuron to, let me say, There is a connection from this neuron to this neuron, isn't it? You can see the connections, few connections. Yes, there is a connection. There is a connection from this particular neuron to this particular neuron, isn't it? From one neuron to this. But there is no connection. For example, here there is no connection. These neurons are not connected, isn't it? These neurons, for example, what is this? These neurons are not connected. That's what I am writing. No connection, isn't it? There are few neurons which are connected. There are neurons which are not connected, isn't it? Yes. But there is no connection here. No connection. Very few connections. You have very few connections. This is biological neural network. Is sparsely connected at birth. These neurons are sparsely connected at birth. But what happens is, by the time kid is 6 years old, just see, by the time kid is 6 years old, which means first 6 years, the network becomes super densely connected. This is very dense. If you notice here, there are millions and millions of connections here. So what's happening here is, let's look at it mathematically. So you have neurons at birth. Let's say each of these are cell bodies. These are cell bodies. Each of these are that's what I discussed even in previous slide also. This one is cell body, this one is cell body, isn't it? This one is cell body, this one is cell body, isn't it? Each of these are cell bodies. Let me show like this. This is cell body, this is cell body, this one is cell body, cell body. Yes, each of these are known as cell bodies, isn't it? So you have neurons at birth. Let's say each of these are cell bodies. There are some connections formed, not very well connected. So mathematically speaking, what these connections are, think of them as weights. Let me say W1. What am I saying? We were saying that first 6 years the network becomes super densely connected. Mathematically speaking, what these connections are, think of them as weights, W1, W2, and so on, W3. Right now, I can say weight between these edges, weight between these two are, let me say, weight between these two vertices are 0. Let me say like this, weight between these two vertices 0. What it means, these two neurons are not connected. Let's say there is a weight of 2.4. Let me assume there is a weight of 2.4. Weight of this particular connection is 2.4. It is connected. Let's say there is another weight with another weight here with, let me say, that is 4.8. This is 4.8. So more weight, there is a more thickly connected. If it is more weight means what? It is more, this one is, as it has got more weight, this one is thickly connected edge or connection, I can say, isn't it? More densely connected this edge is. If you notice here, there are some connections which are very dense. Just see, even if you go to that particular picture, some connections, there are some edges which are densely connected. Just observe this one. There are, if you go through this, just see, these are densely connected. These are densely connected, but these are weakly connected. There are few connections which are very weak, Few connections are densely connected. Few connections weight is high, isn't it? Few connections weight is low. Yes. So the more weight, there is a more thickly connected, more densely connected, isn't it? If you notice here, there are some connections which are very dense. This edge is very thick, isn't it? Just see, this one is we have seen there are some edges which are thick, and there are some edges which are thick. There are some edges which are thin. We can quantify, or we can put it in mathematical terms, what thick and thin are by putting numbers on the edges. You can keep the numbers on the edges. You can say whether it is thick or thin. So the higher the number, the thicker the edge, and the minimum value of any edge is 0, which implies that there is no edge. For example, in this case, between these two neurons, just observe, between these two neurons there is no edge. Between these two neurons there is no edge, and, isn't it? Therefore, for example, in this case, between this neuron and this neuron, there is no edge, isn't it? Weight is 0 because there is no edge present at all. So what's happening is, from the time of birth up to the time kid is 6 years old, there is a lot of brain development that's happening. Of course, just imagine, from the time of birth to kid is 6 years old, they will learn language, isn't it? If you observe carefully, what happens? They used to learn language, isn't it? They will learn language, isn't it? They will learn recognize, and they can recognize speech, isn't it? They will learn recognizing objects, isn't it? Recognizing objects, lots of things that kids' brain learns from 0 year old to 6 year old. I request all of you to go through this lecture. If you have any doubt, please keep a comment. In my next lecture, that is in lecture number 533 also, I will continue my discussion on growth of biological neuron. Thank you very much.